Go live. Okay, you are live. 4 মিনিট ডিলেতে চলছে কি? হ্যাঁ, ওকে। Current viewers 3. So this is my first live video. Okay, and here we are going to discuss some problem regarding linear algebra, and subsequently if I get a response from your side, then I may continue this live streaming or live classes. Okay, so let me know who are there in the comment section. Fine. Okay, so look at question number 1. Here I'm just considering first problem. Problem 1. Problem 1, it says that suppose let Mn R be the set of n cross n matrices, be the set of n cross n matrices with real entries, with real entries, with real entries. Then which of the following? Then which of the following? Which of the following is or true? Okay. So option number 1, it says that any matrix A belonging from M4R has a real eigenvalue. Option number B, it says that any matrix A belonging from M5R has a real eigenvalue. Okay. Option C, it says that any matrix A from M2R has real eigenvalue. Okay. And option D, none of above. So this is our first question, and let's discuss how to proceed with such kind of problem. Okay, and okay, Afizar Hussain, wow. Malik, hi, hi. So Afizar Hussain, achha. So let's discuss over that problem. First of all, let MnR be the set of n cross n matrices with real entries. MnR, n cross n matrices with real entries. That means the entries of the matrices belonging from MnR are of real entries. Okay, that means if you consider M4R, that means you will have matrices 4 cross 4 having the real entries. All the entries are from real number. Okay, and they are saying any matrix A from M4R has real eigenvalue. How to deal? Suppose if you simply consider a matrix. Here we will deal with a counter example. Okay, so if you simply consider like this way, say 0 1 minus 1 0 0 0 0 0 0 0, say 0 1 0 0 minus 1 0. If you simply consider this one as your counter example, in that case you will have plus minus I as your eigenvalues, but your A, it is from M4R, correct? This is from M4. So from where, from this counter example, you can simply conclude that this matrix A has all the eigenvalues as imaginary or complex eigenvalues. There is no real eigenvalue. That means your first option will be discarded and it will be false. Okay, this is your first option's treatment. Now, similarly, you can proceed with your third option. If you simply consider this matrix, say 0, 1, minus 1, 0, in that case, your eigenvalues are going to be plus minus I. Okay, no real eigenvalue. As your third option, that is C option, is also false. Correct? If there is any doubt, you can ask me in the comment section regarding these two options. Okay. So up to this option number A and option number C, there is no doubt, I think. And now, if you are going to concentrate on your second option, just observe it carefully. Second option, for the second option, for option number B, if you consider a matrix A from M5R, then the characteristic polynomial of this matrix A will be of this form, a x to the power 5 plus b x to the power 4 plus c x to the power 3 plus dx square plus x plus f, something like this. Okay, this is going to be the characteristic polynomial. Fine, and look at this characteristic polynomial. If you make it equal with 0, then the characteristic equation, which immediately says that the fifth degree equation, or you can say simply, if you consider this portion, then fifth degree polynomial, it will have five roots, okay, and if there is any imaginary root or complex root, then they will occur in conjugate pair. That means there may be two imaginary roots or four imaginary roots. Okay, in either case you are getting at least one real root. In either case you are getting one real root. Fine. So one real root means there will be at least one eigenvalue for this matrix A, which is real. Okay, there may be three real eigenvalues, but at least one real eigenvalue, it is guaranteed. Thus your option number B is going to be a true option. Obviously your option number D is false. So this is, you can say, a very suitable approach to solve this kind of problem in the exam hall, and very much important type of problem for net exam or GATE exams point of view. Fine. Okay. So now we are moving on to our next question. Next problem, another interesting problem it is. So it says that let x and y, they are from Rn, in Rn, be non-zero non-zero column vectors, column vectors, be non-zero column vectors, then form the matrix, form the matrix A is equals to x y transpose, where y transpose, that is yt, it denotes the transpose of y, and then the rank of A, the rank of A is, these are the options. Option number A, it is 2. Option number B, it is 0. Option number C, at least n by 2, and option number D, none. Okay, so these are the options, and just think about it, how to deal with this problem. Voice is fine. Think about it, how to deal with this question. Solution, look at, let x and y in Rn, x and y, they are from Rn, be column vector. So this will be the form of x. Here n components are there, n components, n components here. This is the form of y, this is the form of x, they have this form. Okay, and here you have the matrix A. A is given by this fellow, A equals to x y transpose, x y transpose. Okay, so x is going to be an type of matrix, no issue with that, but they are asking the rank of A is what, rank of A is what. So look at, x is a non-zero column vector, x is a non-zero column vector. So here is an entity, here is an entity, so on up to components. If you simply go with row reduction type of, row reduction or transformation, similarity transformation, then you will be left out with only one linearly independent row. That is basically, in other words, you are saying that rank of x is equals to 1. Okay, if you say use uh, similarity transformation, then in that case you will only have the fellow as non-zero, and rest of the this element you can make it 0, you can make it this fellow as 0, this as 0, and ultimately you will have rank of x is equals to 1, and similarly you have rank of y is equals to 1. Fine, no issue with that, I think. Clear? Okay. So once these two things are there, then rank of y is equal to 1. Immediately you can conclude rank of y transpose this also 1. Fine. Now you concentrate on this matrix. Rank of A is going to be rank of x y transpose. And you know that for square matrices, rank of A, B, it is less or equals to a minimum of rank of A, comma rank of B. This is a well-known standard result. So we are going to use this result here. So it is rank of A, it is less or equals minimum of rank of X, comma rank of Y transpose. Correct, and already we have this results that rank of x 1 and rank of y transpose is also 1. So rank of A is less or equal to minimum of 1 comma 1, that is basically 1. Okay, so this is one relation you have. And also read the statement again. It says that x and y are non-column vectors. So your A matrix will have at least one non-zero row. Then immediately conclude that rank of A, it is also greater or equals to 1. X and Y, they are non-zero column vectors. Whatever matrix multiplication you do, there will be at least one non-zero real non-zero row for the matrix A. Okay, from there you can conclude this result. So 1 and 2, this 1 and 2 together concludes that rank of A is equals to 1. Okay, so rank of A, the rank of that matrix, it is going to be 1. So your fourth option, that is D option, none, it is going to be correct option. Fine. So this is another question, question number 2 it was, and a very interesting question. Ten 20. Okay, so now we are moving on to our next problem. In these videos, we are covering only problems regarding linear algebra, and subsequently we will also move on to other sections as well. But if you want detailed or systematic videos, then you can also ask me in the comment section, and definitely I will try to provide the videos as much as I can. Okay, so next question here, it is regarding diagonalizability, a famous topic, diagonalizability, and every year and every exam, in fact, they ask question from this area. So question number 3, it is, they are saying that which of the following is true? Which of the following is true? First option, it is a straightforward question. The matrix, this one, 1 0 1 2 is not diagonalizable. Is not diagonalizable. Question number B, the matrix, it is given by 1502 is diagonalizable. The matrix 0101 is diagonalizable. And fourth option is none. How to deal? one result you know, just recall that result regarding diagonalization. Already in my playlist there are plenty of videos regarding this concept of diagonalizability and linear algebra. So you can go there and check out concept how to check diagonalizability for a matrix, and try it by yourself. Okay, one result you know that if eigenvalues are distinct, then immediately it concludes that your matrix it is diagonalizable. Eigenvalues, eigenvalues, distinct eigenvalues, distinct eigenvalues immediately conclude diagonalizability. We have discussed this concept in our early videos. Just go there in the playlist, check out the videos, and definitely find this concept and regarding questions. So for the first option, you can simply find out the eigenvalues, and here this matrix immediately conclude that your diagonal entities are the eigenvalues. So 1 2 is eigenvalue, so the matrix it is diagonalizable, but they are saying it is not diagonalizable, so it false option. Okay, second option, come to the second option. So second option it says that this is diagonalizable. Simply check the eigenvalues. Eigenvalues are 1 and 2. So this eigenvalue it is diagonalizable. So second option is correct. The matrix 0 1 0 1 it is diagonalizable. They are saying it is diagonalizable. Just wait a moment. Distinct eigenvalue immediately implies diagonalizability. Fine, but one necessary condition is that algebraic multiplicity of each eigenvalue, say lambda, it should be equal with geometric multiplicity of that particular eigenvalue. Okay, here you can check out a matrix A. So this matrix 0 1 0 1 values are what? I think so. What are the eigenvalues? No, this matrix it is changed. This question it is wrong. I think it is 1 1 1 0 1. This is the question. This is the question. Okay. So here just rectify the problem. This one, this one. It is 1 1 0 1. This is the matrix. Okay. So look at here the eigenvalues are 1. Okay, and 1. So algebraic multiplicity of this 1 it is 2. Algebraic multiplicity it should equal with geometric multiplicity. And how we find the geometric multiplicity? Geometric multiplicity of 1 it is given by dimension of this particular space, that is 2, minus rank of this matrix. So what is the rank of this matrix? Rank it is given by simply 1 1 0 1, and rank of A minus I, rank of the null space. Yes, rank of the null space. So 1 minus 1 1 0 1 minus 1. For the null space, you will have 0 1 0 0. So rank of A minus I, that is for the null space. So you have 2 minus 1, it is 1. This is geometric multiplicity of this particular matrix. So algebraic multiplicity it is 2, and geometric multiplicity it is 1. Thus you can conclude that AM it is not equals to GM, which is a condition for diagonalizability. So you are getting this matrix as it is not a diagonalizable matrix, but they are claiming it is diagonalizable, so it is false. Obviously, D it is false because already option B is true. Okay. So from here we have the two concepts, like distinct eigenvalues immediately implies the diagonalizability, and the second one, second condition, it is eigenvalues are not distinct. In that case, obviously we have to check AM is equals to GM, whether they are holding or not. Okay. Arab, हाय सर, CSR मैथ एग्जाम की चांस कब लग रहा है आपको? अब देखते हैं, कोरोना तो बढ़ रहा है, कोरोना इट इज मोनोटोनिक इंक्रीजिंग, अभी देखते हैं क्या अपडेट रहता है. ओके. तो देखो, ये जो लाइव सेशंस है, लाइव क्लासेस, तो ये कंटिन्यू होगा. अगर आप लोग फ्रिक्वेंटली जो भी आपका डाउट्स है या फिर जो भी रिक्वायरमेंट है वो मेरे फेसबुक पेज में पोस्ट करो या फिर मैसेज करो, तो उसके रिगार्डिंग जो भी वीडियोस है वो मैं प्रोवाइड करूंगा, लाइव स्ट्रीमिंग के थ्रू ही प्रोवाइड होगा. ओके. एंड CSR नेट एग्जाम कभी भी हो, उसमें कोई बड़ी इशू नहीं है, बट यू शुड बी वेल प्रिपेयर, कि जब भी एग्जाम हो उसके लिए आप मतलब प्रिपेयर होना चाहिए आपको. नेट एग्जाम, गेट एग्जाम है, स्लेट एग्जाम रहता है. ओके. So now we are moving on to our next question. It is question number 4. Let me write down the problem. It is another. Uh, uh, okay. सर ग्रुप थ्योरी भी पढ़वाओगे क्या? हाँ, ग्रुप थ्योरी, हाँ ग्रुप थ्योरी लेटर ऑन स्टार्ट कर सकता है, बट फिलहाल तो यही है कि लिनियर अलजेब्रा, रियल एनालिसिस एंड अप्लाइड पोर्शन लेके चल सकता हूँ अगर प्रॉपर रिस्पांस मिले तो. एंड ग्रुप थ्योरी ऑब्वियसली बीच में मैं करवाऊंगा. ओके. ओके, तो स्टार्ट करते हैं नेक्स्ट क्वेश्चन. So the next problem, it is I think question number 4. question number 4, it says that a system of equation, it is given to us. The equations x1 plus 2x2 plus 3x3 is equal to 1, x1 plus 4x2 plus 9x3 is equals to 1, x1 plus 8x3 plus 27x3 is equals to 1. This system have first option only one solution. The system will have only one solution. Option number B, it is two solution. Option number C, it says that infinitely many solution, and option number D, it says that no solution. So what is the scenario? Sorry, what is the scenario? We have to check it. So look at system of equation, it is given to you. Non-homogeneous system of equation will have, what is the scenario? So already have dealt with this problems in our playlist. You can go there and check out, plenty of videos are there. You can find this type of question there as well. So whenever a system of equation ax is equals to b, a system is given to you, and they are asking you to check whether is only one solution, that means unique solution, more than one solution, in the case of infinitely many solution, and the case for no solution. You have to check rank of A and rank of A augmented B. You have to check the rank of augmented matrix and the matrix, and if the rank it is equal and they are equal with number of variables or dimension of that particular space, that is number of variables or the dimension of that particular space. In that case, you will conclude that the system will have unique solution. Okay, if rank of A, it is equal with rank of A augmented B matrix, but it is less than dimension or number of variables, then you will conclude that your system will have infinitely many solution. Okay, and for the case of no solution, you should have rank of A, it is not equal with rank of A augmented B. Okay, this is the case. Fine. And if you know these results, then this question will hardly 2 minutes to solve. Okay, so let's get started the solution. Okay, so here the last one is 27 3 is equals to 1. So your A matrix, it is given by 1 2 3 1 4 9 1 8 27. Your B matrix, it is given by 1 1 1. So just construct your A augmented B matrix and try to find out the rank 1 2 3 1 1 4 1 1 8 27 1. Okay, now use similar transformation and try to find out the rank of A and rank of A augmented B, and then you can conclude the rest of the portion. So 1 2 3 1 0 2 6 0 0 6. I think here you will have 24. 0. Okay. Now from here, simply multiply this second row by 3 and then subtract from third row. 1 2 3 1, 0 2 6 0, 0 0, I think 6 0. Is it? Just let me check it. Yes, this is the form, final form. Yes, this is the final form. So rank of, from here you can immediately conclude that rank of augmented B matrix, it is 3. Okay, as well as if you consider this portion only, you will have the flavor that rank of A, it is 3. So both of them are equal with 3, and 3 is nothing but the dimension of this particular space. So it is the case for unique solution. Unique solution. They will have exactly one solution. So I think your first option was the case for exactly one solution. Okay, that is the correct option. It was a very straightforward type of problem, but you should have these results in your mind while solving these questions. Okay, so fine. This was for today's video, and as it is a first live session, so it is, you can say, just a starting type of video. There is some doubt from my side as well, and in the subsequent videos I will try to make reduce all kind of doubts and problems from my side, so that the video, it's going to be a smooth one, and you should all enjoy the video as well as prepare well. And if any doubt or any query, then you can go to my Facebook page, that is Maths Beetle. It is inactive page since last you can say more than 6 months. So you can go there and text me whatever you want. Okay, so meet you in the next video with some more problems of linear algebra. Bye.